Hello friends, this video on redox reaction part 9 is brought to you by examfear.com. No more fear from exam. So let's do a recap of redox reactions in terms of oxidation number, right? So the new definition is oxidation is nothing but the increase in oxidation number. Reduction is nothing but the decrease in oxidation number. Oxidizing agents are reagents which increase the oxidation number of another element and they themselves get reduced. Similarly, reducing agents are those elements or compounds which lowers the oxidation number of another element and themselves get oxidized, right? So redox reaction is a reaction which involves change in oxidation number. Now the question is, are all the reactions redox reaction? The answer is no, because there are some reactions which are not redox. For example, this is an acid-base reaction, and if you want to find the oxidation number, let's do it. So our rule says free image of human face, right? So free Ni we can use, O will use, this becomes -2. So this becomes for Pb this becomes +2, right? Similarly HCl this becomes H, right? So +1, so Cl minus will become -1, right? So the PbCl2 this becomes -1, this becomes +2. H2O this becomes -2 first and +1. So if you see in this case, lead Pb, the oxidation number is maintained, right? -2 to +2 to +2. Same. If you talk about oxygen, oxidation number is maintained, right? -2 to -2. If you talk about hydrogen, the oxidation number is maintained, right? +1 to +1. If you talk about chlorine, the oxidation number here also is maintained. So in all these cases, if you see the oxidation number is mentioned, if you talk about lead, oxygen, hydrogen, chlorine, there is no change in oxidation number. This is acid-base reaction. But there are very few reactions which are not redox, but yeah, there are reactions which are not redox reaction. So we talked about oxidizing agent, reducing agent, oxidant, reductant. Let's see some of the popular oxidizing agent in the market. So potassium permanganate is one, we use it a lot in the labs. Potassium dichromate K2Cr2O7 is also a very popular oxidizing agent. Halogens, chlorine, fluorine, bromine, iodine, they are also oxidizing agents. Potassium iodide is also oxidizing agent. Nitric acid is also a strong oxidizing agent. Manganese dioxide is also a strong oxidizing agent. Now let's talk about reducing agent. Ferrous sulfate is a good reducing agent. Then we have stannous chloride is also a good reducing agent. Hydrogen sulfide is a good reducing agent. Sulfur dioxide is also a good reducing agent. Oxalic acid H2C2O4 is a good reducing agent. And metals like zinc, magnesium, they are also good reducing agents. You should know all these things, that if you talk about oxidizing agent, you should have the names in your mind. When you talk about reducing agent, you should have names of all these compounds in your mind. For example, when you talk about oxidizing, you should think like iodine, because that's the oxidizing agent. When you talk about reducing agent, you should think like metals, sulfur dioxide, because with this you become more familiar with chemistry. You know that these are oxidizing agents and these are reducing agents. Correct? Let's take some example here to justify these reactions as redox reaction. As I told, redox reaction is a reaction where both oxidation and reduction takes place. So let's find out. Let's find the oxidation number of Cu and O in this. So with the formulas we have is free image of human face, right? Fni is not used because in most of the case we don't have free or ions. Oxygen, this is -2. So this is -2, this becomes +2. You know why? Because the overall has to be 0. FiOH, so this becomes plus, this equals 0. Why? Because it is free, right? Copper is 0 because free. H2O, O is -2, and this becomes +1. Why? Because the overall has to be 0. Now in this case, if you see, copper from 2 it became 0. Hydrogen from 0 it became 1. That means if you see, here is decrease in oxidation number, this is reduction. Here is increase in oxidation number, this is oxidation. Correct? So this is a redox reaction. Let's take this example. Fe2O3. This is not free, this is not ions. We'll take this guy as -2. This becomes -6. It has to become 6. 6 by 2, it is +3. Correct? CO, again formula, same formula. O is -2. So this carbon is +2. This is 0, free ions. This is -2. -2 into 2, -4. This has to be 4, so that over it is 0, +4. Now if you see, the carbon thing became +2 to +4. Right? Iron 3 to 0. So if you see, this is nothing but reduction. Right? This is nothing but oxidation. Right? Because here we have increase in oxidation number from 2 to 4. Here we have 3 to 0. So this is also redox reaction. Let's take some more example. BCl3. This becomes -1. This becomes +3. Right? This one, free image of human face. H is +1, and then we have lithium and aluminium, so we'll make lithium as +1. Overall, if you see, aluminium will come out to be no. So if you see, this is hydride, right? This is -1 because it's H4 -1, and this becomes aluminum will be +3. Here B2H6, this will become +1. This will become 6 by 2 -3. Here Cl -1, and lithium is +1. AlCl3 minus is +3, and this is -1. Correct? Now let's see. B from 3 to -3. This is a reduction. Cl -1 to -1, no change, leave it. Li +1 to +1, no change. Aluminium +3 to +3, no change. Hydrogen -1 to +1. There's an increase in oxidation. So if you see, this guy is oxidized and this guy is reduced. Right? Correct. Let's take this K, free state 0, F2 free state 0. This is 2K plus, it is 2KF actually, 2KF. Right? So K will have plus and F will have minus charge. This is 2KF actually. So K will have +1 charge, F will have -1 charge, right? Because see, with this rule you get F -1 and then this is +1. So we have done a lot of question of this type in exercise where we find oxidation number, so I am going a little fast. Now if you see here, K oxidation number increased, fluorine oxidation number decreased, right? So this is reduction and this is oxidation. Let's take this NH3, FiOH, H becomes +1, this becomes -3, nitrogen. This is 0, free state. NO, this is O, this becomes -2, this becomes +2, this is -2, and this is +1. Now if you see nitrogen, from -3 it became +2. Hydrogen is same. Oxygen, from 0 it became -2. This is reduction, right? Decrease in oxidation number, 0 to -2. This is -3 to 2. This is increase in oxidation number. This is oxidation. So thus if you see, all these reactions are redox reaction because they have increase and decrease in oxidation number. Correct? So we have to justify if this is a redox reaction. So let's find the oxidation number of all. Using the formula we have, free image of human face, right? So this is O -2. This is -2. Overall has to be 0. It becomes +1. Overall it is 0. This is fluorine free state 0. HF. First I'll give preference to H. This becomes +1, and then overall it has to be 0. This becomes -1. In this case, first preference is O, that is -2. Then H, that is +1. Overall it has to be 0. So let this be X. So x plus 1 minus 2 is equal to 0. So x is equal to plus 1, right? So F is plus 1 here. So if you see in this case, hydrogen was plus 1 here, no change. Plus 1 here, no change. Oxygen is minus 2 here, minus 2 here, no change. Fluorine, if you see, is 0 here, this is minus 1 here. So this is reduction. Here if you see again, fluorine is 0 here, is plus 1 here. This is oxidation. So this guy is oxidation and this guy is reduction. So if you see in the same equation, fluorine is becoming F minus and F plus, right? So one case it is reducing, one case it is oxidizing. Please note here F has charge plus 1, because if we go by the rules, fluorine charge comes out to be plus 1. We'll take some more examples. You have to find the oxidation number of sulfur, chromium and nitrogen in these. In fact, we'll find the oxidation number of all actually, and you have to suggest the structure of this compound, and we'll see if there is some fallacy. So let's start with H2SO5. Let's write the pattern we have. Free image of human face, right? So let's talk about H2SO5. Let me write here H2SO5. There is no free thing here, there is no iron. Oxygen we have, so we'll take it minus 2. Hydrogen we have, then we'll take it plus 1. Let this be x. You solve it, you get 2 into plus 1 for hydrogen, plus x for sulfur, plus 5 into minus 2 for oxygen. This is equal to 0. The total sum formula, that your sum of oxidation number is equal to 0. You solve this, you get x to be what? Plus 8, right? X is equal to plus 8. But sulfur is in which group? Sulfur is in group 16. So according to the rule, the max oxidation number of sulfur has to be plus 6. Plus 8 is not possible, right? There is something wrong there. Let's try to find the structure of H2SO5. So we have structure like this, correct? Let's put the oxidation number of hydrogen, OH, minus 2, minus 2, minus 2, minus 2. But if you put this, we'll again get the sulfur oxidation speed of 8. So we have to make it minus 1 here, minus 1 here. So if that way, if you see, oxidation state will come out to be 6, because oral has to be 0. So OOH, the whole oxidation state of OOH is nothing but minus 1. Correct? So oxidation state here will be 6. Let's talk about Cr2O, Cr2O7 2 minus. Let's apply the formula FiO. Yes, this is minus 2. So let's apply, this is x. So this becomes 2x minus 2 into 7 is equal to net charge, which is minus 2. You solve this, x to become out to be plus 6. And chromium is in group 6. So that's fine, right? So there is no issue in this. Let's talk about NO3 minus. NO3 minus. Again, same thing, free ion O. Yes, this is minus 2. And let this be x. It becomes x minus 3 into 2 is equal to net charge minus 1. You solve, you get x equal to plus 5. And nitrogen in group 15. So group 15 can have 5. That's pretty fine. That is also correct. And I have to find the structure of this. NO3 minus, I know the structure is something like this. It will have negative charge. This is plus 5, this is minus 2, this is minus 2, this is minus 2. So overall it will have a negative charge.
Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.